Actually, it's no internet. It's my pen that I'm using have a button. And I don't need to touch that button, but sometimes I touch it. There's something weird happen. Okay, entonces the video have to part, no? Okay. Focus, guys, please. Cosine 0 es 0. Multiplied by 4 es 4. Ajá, entonces x es 0. X es 4, sorry. And sine 0 is 0. And y, this is y, is 0. And the famous point is the point 4,0. En rectangular, this is rectangular. And this is this point, it's obvious, 4,0. And making sense because in polar, this segment F4 gets the radius, look at that, and the angle is 0. Okay? Let me try 45 degree. 45 degree. Entonces, 45 degree, I plug in 45 degree. Cosine 45 degree es radical 2 over 2. Entonces, 4 radical 2 over 2. Es 2 radical 2. The radius is 2 radical 2. The radius, I substitution here is 2 radical 2. No always is 4, sorry. No always is 4. It's R in general. RR. In this second example, is 2 radical 2 cosine 45 degree. And cosine 45 degree is radical 2 over 2. So 2 radical 2 times radical 2 over 2. Es 2. Radical 2 es 2. Es 2. So the radius is radical 2, but the x value is 2. And the y value is exactly the same because it's, 2 radical 2 sine 45 degree. And cosine 45 degree and sine 45 degree is the same value as 2. And the famous point is the point 2,2. And 2,2 is that point. This is 2,2 en rectangular. And polar would be this segment. This is the hypotenuse, que es 2 radical 2. Look, this is this radius. And the angle is 45 degree. Look at that. This angle is 45 degree. This angle. And polar. Do you see the perfect correspondence with this coordinate and this coordinate? Do you see? Do you see? Okay. Go back. Okay. Now I continue. 90 degree. 90 degree. Cosine 90 degree is 0. Cosine 90 degree is 0. Entonces no radio. No radio means que the point is 0,0. And 0,0 is the origin. Here. So basically the track of the graph walking in that direction. Look. That direction. That was the first point. That was the second point. And was the third point. Do you see that?
Yes.
Now one more. What is one more? Well, 135 degree. I'm walking 45 by 45. Suppose 135. Okay, you plug it in. And the answer in this case is negative 2 radical 2. Why negative? Because in the second quadrant cosine is negative. It's the same value, but negative. So you get 2 and negative 2. I omit the calculation. The point is 2, negative 2. And 2, negative 2 is that point. 2, negative 2. Okay, so you continue travel in that direction. I am here now. And finally, 180. 180 cosine 180 is negative. Well, negative 4 because cosine is negative 1 times 4 is negative 4. And the point is 4 and 0. And the point is 4,0. Wow, guess this point again. I come back to this point. Pero wow, professor, pero it's negative. The negative radius, okay, good. How you plot that in polar? Remember, it's 180. Okay, look, 180 is that angle. Look, one angle, 180 degree. And negative 4. Si es positive 4, es in that direction. but no, it's -4 is in that opposite direction. So we come back to this. Do you understand this?
Yes.
Excellent. Okay, so this is the last time que I am doing by hand a problem with polar. Because no, we have more important tool to do more complicated by hand. I try to make a review or summarize the most important figure. This is the funny part now. The funny part. Okay, I go now to Desmos. Let me know if you see or no Desmos. Do you see Desmos now or no? Do you see?
Yes, I can see it.
Okay, so
I have a question.
uh-huh.
We need to find the points in order to put on Desmos, right? We
No,
find the points by
no,
hand, no?
no. You only add in advance. You you listen to me. Your question is answered. Okay, I have different curve. The Clásica. This is the Clásica. They are more complicated, but this is the most important that you need to know. For example, circle. Circle. We have that circle. Look. Circle with the center and the origin. Radio is 4. I set out 4, pero si es 3, or si es 2, or si es 2.5, or 6. Do you see? When you see the equation R equal constant is circle when the radio is in the origin, and the radio is the radio specification and the value of the R, no? In this case, 3, suppose. Radio 3. Do you understand this? So you don't need to do point by point. No, I do for you because I would like you see where I come from this idea. Okay? Okay. Now, do you remember? Let me delete that part. The example that we're doing before is R equal 4 cosine. Let me change not to 4. 4. Look. Boom. It's a circle with the center is located at the polar axis, and the distance 2, okay, by the way, this distance is half of that number. See the number 4, the center is located here in 2,0. You want, I plot another point, no? 2,0. Unfortunately, in Desmos, when you express the points, Desmos understand que es no en polar, es en Cartesian. O sea, 2,0 es x, y. Que es the mistake I don't remember in the last class. No, I tried to, no. You change the polar plane. You change the polar coordinate. However, the point stay x, y. To do point by point is a little bit more complicated, but you don't worry for this. Do you understand que after I can summarize in the board, but when you see the format que es cosine, something cosine theta is a circle. Circle where the center is located in the x-axis. No? X-axis. Do you see or no?
Yes.
Boom. And si es sine, look at what happened. Boom. Okay, let me try 4 again. 4 again. 4 is the circle. In this case, I put available another line to put the center. The center is located at the point 0,2. Boom. When the sine is on the y-axis, when this cosine is in the x-axis. It's super easy to memorize that. Well, you don't need to memorize. You put in decimals, but okay. Little by little, when you're working with something, when you're working with the multiplication table, little by little, you memorize. When you're working with the trigonometric function, unit circle, you little by little, you memorize. And now it's similar. Little by little, you memorize the most common graphic and polar. Circle, the family of the circle. We have 3 kinds. Repetition again. We have the circle with the center and the origin. R equal constant. The circle with the center is is located on the x-axis, que es cosine, and the circle que es located in the y-axis, que es sine. Boom. Got it, got it, got it. And we finish circle. End the story. Now another figure. Wow, wow, wow. You see, it's amazing. I like so much because it's amazing figure. Look, cardioid. Cardioid is like a heart. You know, it look like in cardioid in Spanish a little bit is a heart, no? It's a heart. So we have different kind of heart. Look, we have cosine positive. Boom. Do you think it look like heart?
Yeah, it does. An apple too.
O an apple, ok. Pero de nombre es cardioid. De matematici, de antichi matematici, you see, wow, it's a heart. Because fell in love, maybe. No, I don't know. Ajá. Yeah. When it's negative, Nuela. Cosine always lie in x-axis. And cosine negative, surprise. Oh, it's the same, but to the left. The heart open to the left. Look above, together. Boom. You see? And when it's sine, si es positive, it's upward. And si es negative, downward. Boom. The most important characteristic to identification de cardioid es que the coefficient is the same. Si es 2, 2, si es 3, 3, si es 4, 4. Si the coefficients are different, no. It's another figure. Que voy a study in few minutes. Okay, do you understand cardioid? Positive to the right. Negative to the left. When the sign positive upward and negative downward. Clear? In the PowerPoint que I sent to you, you can see more clear this. And also, I can send to you in the video this script in the Desmos, and you can explore, no? Okay, and you can change, and you can, because I send my copy, no? They never affect my work. So don't hesitate to. Okay, now limacon. Limacon Nuela look like apple. Actually, no apple. It's orange. Look. In limacon, we have different coefficients, 4 and 3, for example. Look. This is limacon. Limacon sign positive is over. Limacon. Do you see it's no hard?
Yes, I can.
Because hard touch 0, 0,0. When it's negative, down. Boom. When it's positive, is to the right. And when it's negative, is to the left. Limacon. This is called limacon. Okay, the antique mathematicians look like orange, I don't know, or grapefruit, I don't know.
Can I ask you a question, Professor? So the difference between those is the one touches on 0, 0, and this one doesn't, right?
Yes.
Okay.
Absolutely. Yeah. Now limacon, another version of the limacon with the inner loop. What is that, Professor? Okay, when it's cosine positive, do you see that we have inner loop? And this situation happens when the coefficient is different, but the coefficient in front, the trigonometric function is bigger than. See the coefficients are the same. 3, 3, 4, 4, 5, 5. It's a cardioid. See, the coefficients are different. Depending si es bigger, the coefficient not in the trigonometric part is a limacon. However, when the coefficient is bigger, the coefficients can multiply the trigonometric function, we have inner loop. This is cosine, this is sine, inner loop, pero this is open outward, and this is downward, inner loop, open downward, because it's minus sign. It's easy to memorize. It's easy to memorize. Not necessarily memorize, but to get the concept, you know? Okay?
Okay.
Now let's move into the flower. We have two kinds of flower. When you have, it's called a rose. Technically, then it's a technical name. Cardioid, limacon, no inner loop, limacon with inner loop, and rose You have two kinds of rows when you have even petals and when you have odd petals. And let's see what happens with the equations. Look at the equation. In this equation, we have r equal 3 sine 2 theta, double angle, double angle, double angle. But in this case, the coefficients inside the trigonometric function is even, S2, S4, S6. And you see in the first one, bang, how many petals have that rose? How many petals have that rose?
4.
4. And where come from 4? It's a multiplication. The coefficient is 2 times 2. Always multiply by 2. It's double. So this coefficient is 2. Let's see, for example, in the second example, is 4. You expect 8 petals. Look at, boom. 1, 2, 3, 4, 5, 6, 7, 8 petals. Do you see that? And the coefficients in the front, F5, give me the amplitude of the petal. Okay, see F5, entonces bigger flower. And this is 3 cosine. It's the same, but look at the difference between sine and cosine. Sine and cosine, the difference is the same petal, however, rotate 45 degrees. No 90 degrees, 45 degrees. Okay, that petal is starting 0 in cosine, that petal is starting 45 degrees here, 45. Make sense? The flower? Rose?
It does. It does. It looks beautiful.
Yeah. I try to explain the easy way, guys. The book put now another rose with the odd petals. Odd is different. Look, let me show you. The coefficient is 3. Remember, in the other rows, the petal is, the coefficient is 2, 4, 6, it's even number. Now, in this case, odd number. And the amount of petal is different. Look, let me show you. How many petals?
3, Professor.
3 petals. And the coefficient is 3. So they are perfect coincidence with the number here. Although it's easy to memorize. When the number inside the trigonometric function, the coefficient is odd number, it's exactly the same of the amount of petal in the rows. When it's even, no, it's duplicate. 5 petals, we expect. Look at that. You see?
Okay, so there is the difference between those. Okay.
So when you recognize, when you see 3 cosine, 3 theta, oh, it's a flower. It's a rose. How many petals? 3 petals. Because in calculus, we need to work it with the petals. You need to do something inside the petals, right? So you need to know at least intuition, no, about this. And frequently, the students don't remember anything when they take calculus 2 of this. So the professor needs to repeat again. And the last one is Lenny's cat. Lenny's cat is a little bit complicated, but it's important also. We have two kinds, cosine and sine, but include square roots. So this is Lenny's cat.
Infinite.
Exactly. Yeah, it's exactly what to say. Look like infinity symbol, right? And when the sign is rotate, but 45 degrees. Okay, this is the most important. This is the most important figure you can find. We have another more, but I want to send this Desmos script in the video. Okay, send the fragment of video. Okay. Okay, that's too much for today. We continue polar because we have more polar coordinate and more application, polar application. Okay, just stop sharing. You are clear what should you do today? Are you clear? Yes. Everyone is clear?
Yes.
Okay. Tomorrow I need to receive. See, I do not receive, it's because you have some problem and you explain me the problem. Okay, bye-bye.
Bye, Professor. Please see my email.
Okay.